All right, eyes on the screen. How goes it, everybody? So make sure the tables are filled out on the first page, which we did yesterday, second page, third page. Use your calculator to plug in those larger and larger numbers. And then do me a favor, maybe throw in 10,000 in there as well. I think you guys are seeing what's happening. I'm actually going to not share this so you can see. It'll be next week. Yeah, there's a lot of time in this. Okay, I want you guys to look at the first page here, this first page, the one that we filled out yesterday. And I want you to look at number 1, the 2x plus 3 and the x plus 5. So here's how I want you to think about what we're going to do today and into tomorrow. This is kind of my favorite series of talks here. One of my favorite series. I love this course. So I want you guys to think about if you were a millionaire, if somebody had $1 million, and you gave them $5, okay, would they care? Would a millionaire care if they got $5? Let's go even bigger than that. Let's go even bigger than that. What if you were a billionaire? What if you were a billionaire? Would you care about getting $5 if you look at the denominator there? So let's say you had $1 million or $1 billion. Say you had $1 billion and somebody gave them $3. Would they care? Would they care? Okay, no, they wouldn't. So think about this. If you had, say, Beyonce and Jennifer Lopez, I've used this example every year that I've taught horizontal asymptotes and vertical asymptotes, but horizontal asymptotes in particular. Beyonce, I forgot which one was higher, which one was worth more, but who was worth more, I should say. But Beyonce and Jennifer Lopez, one is worth like $250 million, and this is like 3-4 years ago. I'm not going to check again. And the other is worth $300 million. So let's say that's Beyonce. Okay, it could shift. It depends what they're doing. It depends when they're whether they're acting or I know Beyonce's taking a break. I think she just had a baby or babies, like twins. I don't really follow that stuff. But depending on the year, their net worth could actually go up tens of millions of dollars. So essentially, Jennifer Lopez and Beyonce have the same amount of money. Even if one is 350 and the other is 250 million, even $100 million difference, they essentially have the same amount of money. What do I mean by that? Even if they needed the most dire medical procedure, that'll only run into several $1 million, barely even 10 million. In fact, I think the most expensive medical procedures over years are still around $10 million, but he was very, very ill for a long time. They can afford literally every car, every helicopter, almost every yacht, almost every building. Okay, they can't buy everything. I know that. There's things that are worth billions of dollars. They can't buy the island of Manhattan, okay, which is worth hundreds of billions of dollars, I imagine, in terms of the real estate. But they can buy essentially anything, okay? Even things that just give us like pleasure, like very fancy cars or fancy homes with too many rooms and bathrooms, etc. So they have the same amount of money because they have so much money. It's so large. So let's get to this here. So if you had $1 million and somebody gave you $5, you really wouldn't care. If somebody had $1 million and somebody gave you $3, you really wouldn't care. But what if somebody was going to double what you have? What if somebody gave you another $1 million on top of your 2? Take a look at that 2x plus 3. What if you had $1 million and then somebody doubled it? Would that matter? Would it matter if somebody doubled how much money you had? Yeah, it would. It would. You'd have $2 million. You're doubling what probably is your worth. So you guys know, you've seen this before. An asymptote is a line or curve. Okay, we're not going to do curves in this course. An asymptote is a line or curve where the graph gets arbitrarily close. The graph gets arbitrarily close but never touches. So an asymptote is a line. All right, see how far the bullet points are because I made the emphasis. We're not going to get into curves in this course, but an asymptote is a line. Please, guys, you have to have x equals something or y equals something. I've said this many times. It's got to be a line. You can't just say 1/2. You can't just say 5. It's got to be x equals 1/2, y equals 5, etc. So to solve for a vertical asymptote, which you guys have done many times, you set the denominator equal to 0 and solve for x. If we have 5 over x squared minus 81, what is the asymptote? or asymptotes? All right, you just got it marked wrong. You just got it marked wrong. There you go. X equals. It's got to be x equals -9, x equals 9. X equals -9, x equals 9. Good, because you'd factor and then solve. All right, likewise, what are the vertical asymptotes here? Just vertical asymptotes, not talking about horizontal. Good, yeah. X plus 6, x minus 6 are the factors, and then you set it each equal to 0. So let's get into the rules of horizontal asymptotes now. So with horizontal asymptotes, the reason I started talking about J-Lo and Beyonce, is she even called J-Lo anymore? Jennifer Lopez, Beyonce, worth hundreds of millions of dollars. So I want you guys thinking big. I want you guys thinking as big as your dreams. I want you guys thinking as big as your dreams. And what do I mean by that? I want you thinking of the distances between galaxies. I want you to think about America's entire economy. I want you to think about a corporation's debt. And I want you to think, how long ago were the dinosaurs? Okay, so let's look at some of these answers here. Distances between galaxies are trillions of miles. The America's entire economy, which we judge whether we're in a recession or we're in a period of growth, the GDP, that's trillions of dollars. All right, a corporation's debt is billions of dollars. How long ago were the dinosaurs? That's millions of years ago. Now, one thing to note, a corporation's debt, how long ago were the dinosaurs? We're not going to really talk too much about negative numbers. We're not going to really talk too much about negative numbers here, okay? I want to talk about putting in like just positive large values in. Positive large values in for x. Okay, so take a look at this. We have 2 over 1, 3 over 1, 40 over 1, and 50 million, excuse me, over 1. So this seems a little ridiculous. I'm just saying that when you go on the number line, 2, 3, 40, 50 million, you can see that the numbers get bigger. That's why I have less than symbols here. I have them over 1 because I'm showing that any number can be made into a fraction, right? Okay. So as the numerator gets bigger, what are we approaching? What number are we getting close to here, guys, as we go from left all the way to right? Yeah, we're getting close to infinity. That's why I tell you guys, on a graph, infinity is all the way to the right. Let's talk about the denominator getting bigger and bigger and bigger until we get really, really, really huge. We're going to get really, really huge. Okay? So as the denominator gets bigger, what are we approaching? Put in the chat box. Be careful. What are we approaching? Take a look at what's on the right after these equal signs. Yeah, we're getting closer to 0. We're getting closer and closer to 0 as the denominator gets bigger and bigger and bigger. Okay, so take a look at this function. Sorry, it's x over x squared. Don't simplify it. Don't simplify it. We're going to plug some stuff in here. Yeah, we're not going to simplify it, though. If you were to put 5 in for x, you'd have 5 over 25, right? And that reduces to 1 over 5, and that equals 0.2. That is not close to 0. So if you put 5 in for x, you'd have 5 over 25. That's 1 over 5. That's 0.2. That's not close to 0. Okay, I'm not talking about putting 5 in for x on any of this stuff. Okay, I'm talking about putting enormous numbers in for x. Okay, when I'm talking about horizontal asymptotes, we're talking about putting enormous numbers in for x. We're just dealing with the positive right now. That's it. Okay, so let's take this x over x squared and let's put an enormous number in, like 1 million. So if you were to put 1 million into the numerator, sorry, it's a little hard to say, we'd have 1 million in the numerator, but we'd have what in the denominator? What number is this, guys? 1 million squared is what? Yeah, McKinley's on the right track. That's what we're essentially doing as we get bigger and bigger. What's this number on the bottom here? We have 1 million on the top. What's 1 million squared? What's 1 million squared? Yep, that's a trillion. Yep, 4 sets of zeros. 3 sets of zeros is a billion. 4 sets of zeros is a trillion.
So now you know what all these boys are. Let's do this. We have Bobo. That means bigger on bottom. Bigger on bottom. Then put a slash through this, 0. Okay, it's not, that's a number, that's not an O. Bigger on bottom than 0. What's bigger on the bottom? What's bigger on the bottom? This acronym stands for bigger on the bottom. What's bigger on the bottom? What are we talking about? I didn't mean to do that. The exponent of x. Good. Yeah, not the coefficient. Okay. So let's cut to the chase here. You guys ultimately got 0.00334. What'd you guys get for 10,000? What'd you guys get for 10,000 in this table here? This was like 0.02045. So you can see how you had 2 pennies and now you have none. What did 10,000? Point one. Oh, okay. 0.000001, like all the way over there. Good. Okay. So the number y1 gets very close to is 0, and they give away the answer here. So what's the equation for the horizontal asymptote? It is y equals 0. Or what's the other way to say that? You can say the x-axis. Okay. Factor the denominator. Factor the denominator. What'd you guys get here? What'd you guys get here? What are your factors? There we go. Yes, it's going to be x plus 5 and x minus 2. That's what the denominator factors to. So you have x equals -5 and x equals 2. So what are these things going to be? They're going to be your vertical asymptotes. All right, and now sketch the graph of the function. This is why I told you guys to throw your calculators away. We're going to have x equals -5, 1, 2, 3, 4, 5. All right, usually asymptotes are drawn with dotted lines. Okay, let's name this guy. This is x equals -5. And then we have x equals 2, another vertical line. Let's name this guy, x equals 2. Name our asymptotes. And then y equals 0. So you can just put this along the x-axis here. Y equals 0.